We say it as log base b of a equals x. And so you can actually rewrite this in exponential form. Here's our base, all about that base, There it is. Okay, the base on the log, this is really important. You're going to take a full unit test over this, by the way. We're not splitting it because we kind of just do the same thing over and over. The base in the log is the same base as the exponential. Shouldn't need your laptop. You're going to close it. So when we go to rewrite it, if you want to just watch right now and then write it in a second, it looks like this. I always draw an arrow. I don't know why. I just think it helps me. It's kind of like follow the path. B to the x power is equal to a. So the base is the same. It's equal to the exponent. So I'll highlight it again. The logarithm is always equal to the exponent. So your base is b. B to the x power is equal to a. You can rewrite it like that. And that's what you're going to do a lot of today, is take the logarithm and rewrite it as an exponential. Okay, let's do these first ones. Rewrite the equation in exponential form. We're going to do this on Delta Math today as well. It's all about that base. What is the base? 2. Okay, and then we know the base is 2 for the exponential. And so now we're going to rewrite it. I just draw an arrow to help me. So 2 to the 4th power is equal to 16. A logarithm is always equal to an exponent. Okay, and then check your perfect chart. Is that right? 2 to the 4th is 16? Mm-hmm. Yes. Okay, that's it. We're just rewriting right now. Next one. What's the base? Number 2. 4. All about that base. Okay, 4 raised to 0 is 1, because anything to the 0 power is 1. Okay, do these two make sense? Okay, all about that base. Number 3 is a base of 12. 12 to the 1st power is equal to 12. Well, of course it is. And now we're going to start to get a little bit more fancy. The base on the next one is what? 1/4. Okay, when you have a base that's a fraction, please put it in parentheses, like so. 1/4 to the, it's equal to the exponent. Negative 1st power is equal to 4. Okay, there's something here we need to learn for today in case you haven't learned it yet. When you have a negative exponent, it sends things to the other side or flips a fraction. Can you stop? Negative exponent. Flips the fraction. So you can see that 4, those 4s are not on the same level. That's maybe one way to say it, right? The 4 on the left side is in the denominator. The 4 on the right side is in the numerator. And so in order to make it send up to the top and become 4 in the numerator, you'd have to flip the sign of the fraction or change the sign of the exponent, which would send it up. We'll do more examples of that. All right. Let's look at the next one. This one says rewrite each in logarithmic form. So again, it's all about that base, What is the base on number 5? 5. Okay, so the log base is the one that's kind of like the subscript. We should write it a little bit smaller. Log base 5. Okay, and then you can draw an arrow if that helps you. Whoop. Log base 5 of 25, and it's always equal to the exponent of 2. So you can see I put the base kind of smaller, and I'll highlight that so you can see that the base is the same. So just rewriting. What's the base on number 6? 10. Okay. So log base 10 of 0.1 is equal to -1. There's another example there of, let's talk about y here. Y. Here's y. Okay, if I have 10, just explaining a little bit, 10 to the negative 1st power, when you have a negative exponent, you can send it to the other side of the fraction, and so it would become 1 over 10 to the 1st, which is 1/10, or 0.1. Okay. Let's look at number 7. This one's going to get a little bit dicey. Here we go. What's the base? 8. So log base 8 of, you can loop around, follow the path. Log base 8 of 4 is equal to 2/3. Okay, that's rewriting it, but again, we're trying to learn. So that's already in log form, but for the sake of learning, remember that anytime you have an exponent that's a fraction, you can rewrite it as a radical. So here's your second thing today. Fraction exponent becomes a radical. I know you probably thought you were done with radicals, but not quite yet. Not really simplifying them per se. So this one becomes, let's see, the bottom number is 3. So it's the cube root of 8. And then it gets squared. Do you remember this? Man, I hope so. We just did it. Okay, what's the cube root of 8? You can use your perfect chart if you need it. 2. Okay, and what's 2 squared? 4. Okay. So do you see why? Here. Ta-da. Okay. Just keep that in mind. Next one. We're just going to rewrite. The base here is 6. So all about that base. Log base 6 of... Anytime you have a fraction, please put it in parentheses. So log base 6 of 1 over 216 is equal to -3. Again, that's another example of 6 to the third is 216, but because they're on different sides of the fraction, the exponent has to be negative. Sorry, I would put that below it, but my little logo's in the way. Okay. If I had like log base 5 of 5, it would have to be equal to 1. Because if I'm like, okay, that's equal to x, be 5 to what power equals 5? Well, it has to be 1. Does that make sense? Sort of. Sorry about the 8 there. Anything log base 5 of itself is equal to 1. Okay, this other one thing here is saying anything log base b of 1 is equal to 0 because anything to the 0 power is 1. That's what it's saying. Okay, so today you're doing delta math, and this is the first skill it's going to have you do. You ready? All about that base. What's the base on number 9? 4. Okay, here's what you're going to do to help yourself here. You're going to say is equal to x. Okay, and then we're going to draw the little arrow thing just because it helps me. I don't know. So 4 to the x power is equal to 64. 4 to the x is equal to 64. And then you can use a perfect chart or use your brain to figure out, okay, 4 to what power is 64? You're just trying to find the exponent. That's it. What is it? 3. 4 times 4 times 4. Do you see it on your perfect chart? You would say you go 64 and figure out, like, look and see where you can find it. Or actually use 4 on the end side and follow it over. That's it there. Okay. Again, set this one equal to x, and then you can loop-de-loop around here to write an equation. 5 to the x power is equal to 1/5. And then you're asking yourself, how do I make it become 1/5? Because obviously you already have 5 and 5. So you don't need to like do 5 to the second power or third power or anything like that. How do I make it send to the other side of the fraction? Negative exponent, yes. Okay, so if this was a -1 power, I'm going to do an arrow over here, 5 to the -1, that sends it down to become 1 to the 1 over 5 to the first. Okay, so your answer is x equals -1. This is another example of the negative exponent, okay? If you're on delta math, it's probably not going to want you to put the x equals. It's just going to want you to put the answer, -1. Okay, let's try the next one. All about that base. It's 1/5. So again, please use parentheses. 1/5 to, or say x is equal to 125. All right, can you work at your table? At least try and figure out how do I get from 5 to 125. So if your n is 5 and you follow over 5 to the third, right? Okay. You know that 5 to the third? I'm going to write it out to the side, okay? 5 to the third is 125. But you can see that your 5 is not in the top of the fraction like that. It's in the denominator. So that means that yours has to be not positive 3, but negative 3. Right, okay. Because it's on the other side of the fraction. So here's my pro tip. Here's what you need to ask yourself. Are these numbers I have, are they on the same level or are they on different levels? If they're on different levels, then you have to use a negative exponent. These ones are on different levels. So yes, it's 5 to the third, but it has to be negative. Okay, last one's kind of tricky. Your base is 36. Don't be deceived. So 36 raised to x is equal to 6. It's the square root of 36, right? Gets you 6? No. What's a square root? It's an index of 2. Okay, so if it's a square root, then you write it like this, right? It would be 36 to the 1/2. Do you remember that since we just learned it like 2 weeks ago? Maybe it has to come back to you today. Today's the time. Yeah, 1/2. Okay, tell the people at your table, why is it 1/2 again? You're going to see one that says just literally log. That's called the common log. And it's all about the base. It has a base of 10. So it's not going to tell you it has a base of 10, but it does. And if you're on Desmos, you literally just type log, and it's going to know right away you're talking about the log. There's also another button on your calculator that says ln. This is called the natural log, and that is your log base e. Remember, e is that 2.71 number, kind of like pi. It's a special number that you get by doing, eventually as x reaches infinity, that's what you get. So this is log base 10, log base e. Your calculator only has these bases unless it's really expensive and fancy. Okay, so if you want to just type in your calculator, log 8, and you're going to get a decimal, it wants us to do it to 3 decimal places, so that's what we're going to do. So type it in yourself. You're not dumb if you don't know how to use your calculator, but it is pretty dumb to not practice. So I would do that if I were you. And we're going to use the approximate sign since we're rounding, 0.903. Is that what you have? 3 decimal places? Okay, and then you type the next one. The natural log is what you see here. So this one is called the common log, because it's log base 10. It's an invisible 10 right here. This one is a natural log. It's log base e. Okay, you just type it in your calculator. It should be a negative, I believe, which means it would be a negative exponent, which would send it to the other side. I'm doing the same kind of stuff in college algebra right now, so I get confused between my two classes. 1.204. There you go. And again, I use the squiggly equal sign because I'm rounding. Okay, now this is the last thing. You actually don't need a calculator for this. Here's what's cool about exponentials and logs. They're inverses of each other, meaning they will undo each other. Remember, we just finished a unit on inverses. So your x's and y's flip, and they also cancel each other out. So if you see exponentials and logs, you can cross out if they have the same base. So look at this one. This is, you can rewrite as 10 raised to log base, it's a natural log, so it's log base 10 of 4. If you don't see a base for the log, log, it's 10. And here's what's cool. These actually just cancel out because exponential base 10, log base 10, your answer is 4. You're going to see this on Delta Math today. Okay, the next one is weird because they're not the same base, right? Because your base here is 5, and then you have a 25. So you have to see if you can get them to be the same base. How can I rewrite 25 as a base of 5? 5. Here, I'm going to highlight it. What is 25 in terms of 5? 5 to what power? 2. There you go. 5 squared, right? So I'm highlighting what I'm switching over. So I'm just swapping out. I'm saying, yeah, 25 is 5 squared. And then you can cancel out. log base 5, exponential base 5, and you're left with this, which is 2x. That's your answer. I'm not solving anything further than that. Okay, this one is a natural log, is what we call it. So log base e, if you wanted to write it like that, of e to the 2x power. I know this is weird, okay? You have a log base e and an exponential base e. It's all about that base. So you get to cancel those, and you're left with the same thing as last time, 2x. Okay, and then last one, you have an exponential base of 4 and log base of 4, so they cancel, and you're left with 5. Because they are inverses of each other, they undo.